Okay, so today we're going to expand upon the structural application and start to integrate it with um, some more regular architectural conditions, essentially. So um, basically, what I'm going to do just to get started is I'm going to create a sort of structural framework, and it's going to be this, sort of peak tower sort of thing. Then we're going to actually do, and that's going to be, and we're going to map a volume to it. And then with that volume, we're going to create a massing for the building, which is going to allow us to create floor plates, which will also allow us to map a facade. Okay, so I don't really have a good sample for what we're doing, but I just wanted to show you how to get it integrated into something that is an architectural idea. Um, rather than something that's purely structural like the bridge we did over the past 2 or 3 days. So without further ado, what I'd like you to do is jump into your top view and just create some kind of volume. And in fact, I think what I would prefer to do in this case is just let's do a rectangle. And it doesn't really matter the size, but try to make it something that's kind of a building size. So maybe 50 feet wide by 20, 30 feet, 30 feet or so. Something like that. And what I'm going to do here in Grasshopper is I'm going to reference that in just because this is going to be the base of my building to get started with it. So I'm just going to reference that in. So that's going to be under curve, and I'm going to set one curve to the rectangle. This rectangle is going to be extruded upwards, and then I'm going to use that to generate structure for it. We'll talk about the structure in a moment, but so what I'm going to do is surface, freeform, and extrude. And I'm going to extrude the curve, obviously, in the Z direction, and so I'm going to grab empty parameter. Empty vector. Okay. Yeah, so I'm going to grab a vector unit Z. And since we're reading in feet, make a slider of some kind of significance. So maybe 0 to 100. Something like this. You can just change your units at the bottom. Okay, so from this, essentially what I want to do is create I want to create a rectangle in all four corners in order to generate the geometry that I'm trying to work with. The challenge here is that when I'm mapping geometry into the corner, or basically like a structural shaft for a column construct, I have to do it so that it goes into the toward the center of the building, and so it's going to look a little funny. And in fact, there might be there probably is a smarter way of doing this than the way I'm about to do it. But what I'll do is actually grab the surface. I'm going to create a surface at the bottom. I'm going to grab the four corner elements. Well, no, do I want to do that? Yeah, I do. I'm going to what's a smart way to do that? Well, I'll do it manually for now, and I'll think of a smart way later. But I'm going to grab the four corner surfaces and just extrude those up as well. So that's going to look like this. I'm going to param and grab a surface. And if you plug the curve directly into the surface, it creates a surface like that for you. And then with that surface, I am going to subdivide it. So you go to domain, divide domain squared with your ISO trim, connect all the triangulated elements here, and then just put a slider on here. 0 to 10 will be fine. I made mine somewhat rectilinear, kind of in the direction of the skinny side of the building. You don't have to do that, but I did. And then I could manually select each of the corners, but I think what I want to do is grab the 4 farthest points. Well, do I want to do that? No, I'm going to manually grab them now because I don't want to go through trying to figure out the farthest points thing right now. So this will have to be deconstructed. And then I'm going to need my list items, right? So I'm going to go to list item with slider 0 to 3. Or no, I'm sorry, not 0 to 3. It's going to be like 0 to 20 something. Just do 0 to 30. Make sure that list is flattened, and then you can start selecting them. So that corner one is correct. Let me turn this off. Right, so there's the first corner right there. So this one is correct. So I'll move this up to the top. And then I'm going to need to find the other corner, which is that one. And then I'll find this other corner. You could do this with math, actually, to do it in a pretty smart way. 29. Okay. So I grabbed my 4 corners. I'd like you guys to do the same there. And the last thing that I want you to do is to do a second extrude. And we're going to just plug in exactly the same unit Z. So we're going to go to Surface, Freeform, Extrude. Except this one is going to extrude all 4 of these, and I think it'll allow us to do all 4 of them at once. And then we can plug in the unit Z there. Any questions? So right now this is going to be the framework for my structure. Right now it's an extremely robust structure, mind you, and I'm not doing anything that's super crazy for it. I just want you to understand, some clever ways of getting to that result. So yeah, hang tight for a moment and we'll get started on the next.